Hello, this is AKMS. Today we're going to do parallelogram properties. From the first two videos that I was trying to explain about the quadrilateral, if what's going to happen quadrilateral have two parallel sides or two parallel sides with being two congruent sides, what's going to happen. We got the definition of a parallelogram. So from over there we got the definition of a parallelogram. Parallelogram is a quadrilateral first. Lateral that has quadrilateral with, let's say, with two. So let me draw. Okay, here. All right, something like that. Perfect. And let's draw the A, B, C, T. Okay. So what do we have? We have one pair of parallel, and the other also is parallel. This is also parallel to this. So two parallel with two pair of parallel and congruent sides. What does it mean? So these two sides are parallel, AB to CD and BC to AD are parallel, but AB congruent to AC and BC are congruent to AD. BC no need to be congruent with CD. All right. Okay, so we have it from this definition that AB is parallel to CD, and at the same time AB is congruent to CD. Next, BC is parallel to AD, and at the same time it's BC is congruent to AD. Okay, we have from the definition. Okay, now let's get into the first property, adjacent angle. What's going to happen with the adjacent angles of the parallel? Okay, when we say adjacent, we need to neighbor angles. So if we're going to start with A, its neighbor it is going to be either angle B or D. Okay, doesn't matter which one. So let's suppose I'm going to choose angle NB. It doesn't matter where you're going to start. If you start from C, your neighbor is going to be either B or D. If you start from D, your neighbor is going to be either A or either C. Okay, this is the adjacent angles. So doesn't matter which angle we're going to choose. So let's suppose we start from A. If we choose A and we have two options, either B or D, we're going to choose, let it be B. So two adjacent, angle A and angle B are adjacent, which means neighbor. Okay, how they relate? Let's in most geometry problem we're trying to find, maybe let's try there is some, how they're related. What do we know? We know two things, that these two lines are parallel. Nice. Now let's see, these two lines are parallel, and we have AB is a transversal, or we can use alternating interior or exterior angles, consecutive. All right. So we're gonna say on BC being parallel to AD, we have an transversal AB. What we have? We have the following. Okay, we have the following. What do we have? What do we know? We know that this angle, let it be, let's let it be angle alpha. Let it be angle alpha. Let it be angle alpha. Angle alpha is, if I extend AB, angle alpha, let me extend on both sides. Okay, if I extend this, angle alpha will be congruent to what? Angle alpha will be congruent to angle, let's suppose this is alpha prime. Okay, it's by consecutive congruent to alpha prime by consecutive postulate, by consecutive angle postulate. All right. Now, let this angle be some angle beta. So, what do we know? Alpha and beta, how they relate? Okay, they're on the straight line. Okay, so there was first, second, alpha prime. Sorry, here alpha prime plus beta is on the straight line, which is supplementary. They are supplementary. Alpha and beta, they are supplementary, which means supplementary. We can say, which means alpha prime plus beta is 180 degree. And by substitution, which we did it here, consecutive angles are congruent. Third, alpha plus beta is 180 by substitution. Okay. So, if these angles of a parallelogram, they are supplementary. Perfect. So we can choose any angles. So let it be this one with this one supplementary. Okay, this one with this one supplementary. Okay. First one is done. Let's get into the second one. All right. Second property, opposite angles. So we know that opposite angles, it should not have need to be the neighbors, but look the opposite angle, which is for A, it's gonna be C. For A, it's gonna be C. Okay. Opposite angles. All right. Let me copy and paste. All right. Here I will remove this part. Okay. All right. We're gonna work with 3 angles, alpha, beta, and let's see B gamma. Let's see B. This angle B gamma. All right. So these two angles are supplementary. Let's write down. These two angles are angle A, angle alpha, and angle gamma. They are opposite angle. How they relate with each other. Let's try to find their sum. Or maybe, I don't know, something like that. What are we gonna do, we're gonna use same story. We're gonna use the adjacent, the one that we did it earlier, adjacent from, we can say, by adjacent angles first. I'm gonna use the adjacent angles twice. First, adjacent, let be for C, adjacent is going to be B, adjacent gamma plus, or let's start with alpha plus beta is 180 by adjacent angles. Now for the second, what we can say, beta is beta plus gamma. Let me do like this, gamma plus beta, because commutative property, you can switch the places, is equal to 180 degrees by adjacent for this side, adjacent angle property. Okay, number 3, what we can do the maths here, algebra. We can subtract these two equations. If we subtract by subtraction, okay, if we do subtract, let's do it here, subtract alpha plus beta, subtract gamma, here signs change, subtract b, and 180 minus 180. Okay, so what do we get here? Beta cancel, 180 will give me 0. What do we have? We have left alpha minus beta is equal to 0, which alpha minus beta equals 0 whenever alpha equal to beta. Okay, so 3, which means alpha congruent to beta by subtraction. That's it. So what do we get from this important calculations? We got that opposite angles, they are congruent. Okay, opposite angles are congruent. Sorry, alpha to gamma here. My mistake, my small mistake. Alpha to gamma. All right. Alpha to gamma is alpha to gamma is congruent. Opposite angles are congruent. Okay. We got two things. Adjacent angles, they're supplementary, and opposite angles of the parallelogram, they're congruent. Perfect. Adjacent 180 give us 180, and these are, or this one, are congruent. Let's get into the third one, diagonals. What's going to happen if we draw diagonals to the parallelogram? Okay, let me choose my parallelogram. All right, this is here, and number 3, diagonals bisect. Okay, let's try to prove that. Okay, what are we gonna do? We're not gonna work with angles, these angles right now, later maybe. Okay, so we have our diagonals, our parallelogram, with a definition of the parallelogram given this definition. Okay, which means this side is congruent to this side at the same time, they're parallel, and BC is parallel to AD. Now let's construct two diagonals AC and diagonals AD. You try to prove that they bisect. What does the bisect means? That their intersections. Let be E. Point E, the diagonals intersections. Let diagonals AC diagonals intersect diagonal BD at point E, which means we're gonna try to prove that BE is congruent to ED because it's bisects, and AE is congruent to, so this part is congruent to this part EC. The first part is congruent to this first, so when we divide the diagonals into two. Okay. Let's try to prove it. How are we going to prove it? For proofs, of course, we're going to use ACE, the postulate triangles like ASA, side, angles, or side angles, sides. We'll try to use one of those. Okay. Let's look at the first triangle. This triangle ABE. Okay. And CED. Okay. Okay. We have triangle ABE and triangle CED. Now, what I know that this angle is the same as that angle. Okay. First, by vertical angles. First, let's choose AEB. So angle AEB is congruent to angle DEC. So we start from here. We have to start from there. CED. Okay, angle CD by vertical angle theorem. Okay. Number one. Okay, we have angle. So we can use either ASA or SAA. Okay, we have angle. One is we have it. Okay, we need to prove those sides. Okay, one angle, we have it. Okay, this angle is the same as that angle. Now, how we can work with these two angles? Oh, pretty easy. Okay, what do we have? We know that these two sides are parallel, and we have the oh no, we're gonna use these two sides. Okay, all right. I'm gonna use these two parallel sides. So these two parallel sides, and we have a transversal diagonal AC, which means alternating interior. This angle must be congruent to that angle. All right, same story if we choose BD, and with these two angles, this angle must be congruent to that angle. Okay, perfect. So this angle is the same as that. This angle is the same as this one. Let's write down number 1 and 2. For 2, angle on, okay, let's do a this angle, so which means BAE angle BAE is congruent to, start from BAE to this side, so for this AC diagonal we're gonna start with DCE is congruent to DCE. Okay, BAE is congruent to DCE, yes, correct, by alternating interior angle theorem. We have to name this on transversal AC diagonal. Okay, this is transversal. I need to make sure which transversal will work. Of course, this is parallel, and parallel these two lines. Okay. Similarly, we can use this angle, ABE. Angle ABE is congruent. We switch these places. Angle CDE. Yes, CDE. Yes, correct. On this transversal BD by alternating interior angles on transversal BD diagonal BD AC diagonal. Okay. All right, we have 3 angles. Now, in order to do that, to do something, we need one of the sides. Oh, great things we already have from the definition. These 2 sides are the same by the definition. So number 3, parallel. Okay, so okay, AB is congruent to CD by definition of a parallelogram. Okay, you can say also given. Okay, so what do we have? We have side and 2 angles. So if we have side and 2 angles, what do we have? Angle, side, angle. So number 4, these 2 triangles, let's say ABE, we start from here, so with this diagonal, so we're gonna say CDE. Okay, ABE congruent to CDE. Triangle ABE is congruent to triangle ABE is congruent to triangle CDE. All right, CDE, ABE to CDE. Now, if the triangles are congruent, their parts are congruent. All right, which means we have to say by angle side angle theorem postulate. Let's see, and number 5 by the side, so which means BE is congruent to ED, side BE is congruent to DE, and AE is congruent to CE, and AE is congruent to CE by congruent parts of congruent triangles are congruent. CP, CT, C. Okay, it's done. So we got that diagonals intersections are bisectors, which means side BE is the same as side ED, and AE is the same congruent with E and C. Okay. Thank you very much.